Okay, top of page 14, we want to find the volume of the solid formed by revolving the region bounded by the following graphs. So we have y is equal to the square root of x, and y is equal to x squared about the x-axis. So again, about the x-axis is the same thing as perpendicular to x, which means we have y is equal to something dx. That's going to be what we have for our integral. So what we need to take a look at first is, what does our graph look like? So let's see. The square root of x goes like this, x squared goes like this. So we would take a look at our graph. So let's go like this and like this. So let's see if we pick some point 0, 0, 1, 1. Let's see, 2, 3, 4, 2. Okay, so the graph is going to go like this. That's this one. X squared 0, 0, 1, 1, 2, 4. It's going to go up here. So that means we're going to have this teeny tiny section like this. If I could have drawn it where they intersected each other. But what we're looking at is this region right here. It's teeny tiny. Okay, and if we're talking about, first of all, this is y is equal to the square root of x, y is equal to x squared, and we are revolving about the x-axis, meaning like this, okay? We are taking a look at this big here, and then here. So because even though this portion of the graph is touching the x-axis, the whole thing is not touching the x-axis, so this is actually going to be a washer when this is revolved, because this is going to be some open region here. So this little part right here is little r, because this is the bottom, and this big part right here is big R. So this is what we need to look at. First of all, we need our bounds. So let's go over here and calculate our bounds. In order to calculate the bounds, even though I could probably see it here, if I didn't because my graph was so terrible, I set these two equations equal to each other. So the square root of x is equal to x squared. To get rid of the radical, I square both sides. So this becomes x is equal to x to the fourth. Move this over. So x to the fourth minus x is equal to 0. Factor out an x. And then solve each one. So we're saying that x is equal to 0 and x is equal to 1. Okay, that should match up. So these are my bounds. So I have those. Then I need to get my setup. So remember, our formula is going to be a top minus a bottom because it's perpendicular to x. And we also have the volume is equal to pi times the integral from a to b. Big R squared minus little r squared. In this case, it's dx, where this is going to be the top and this is going to be the bottom. So my top minus the bottom, which is 0, and then it's the bottom minus the axis of revolution, which is 0. So big R will be the square root of x, and little r will be x squared. So now we can write our setup. So the volume is equal to pi times the integral from 0 to 1 of big R squared, which is the square root of x squared, minus little r squared, which is x squared squared. And remember, this is dx. So right now we're not using a calculator, so we want to simplify this. So this is pi times the integral from 0 to 1 of x minus x to the fourth dx. We'll integrate. So I'm going to move over here. This is pi times 1/2 x squared minus 1/5 x to the fifth to be evaluated from 0 to 1. So now we'll just plug in. And when your bottom bound is 0 and everything has a variable in it, this is just going to go away. So you have pi times 1/2 minus 1/5. So if I do f of b, which is 1/2 minus 1/5 minus f of a, this becomes 0. So this is pi times 5/10 minus 2/10. So my volume of this teeny tiny little area revolved around this axis of revolution is 3 pi over 10. Okay, so that was with respect to x. So we did a disk and a washer. Now we're going to talk about disks and washers perpendicular to y. Okay, perpendicular to y means our equation is in x equals, and this would be dy. So we'll have a similar method, okay, for both disks and washers. I'm going to move through this a little bit quicker because we've already seen it. But when we're talking about a disk, again, because this is perpendicular to y, remember your format is going to be right minus left. So in this case, this is going to be a disk, because if you look here, my right is u of y. My left is actually where x is equal to 0. And then I have my bounds here from C to D. And then we have our axis of revolution, which is right here. Okay. Okay, so what happens is this will then be revolved around the y-axis to create this disk right here. Okay. And what we have is pi times the integral from C to D of u of y squared dy. Because this here, again, just like that pi r squared, this u of y minus 0 is going to be your radius. Okay, and then the same idea here, if you have this disk in between, and we're dealing with the right minus the left. So let's take a look at this. This is my right here. Okay, and we're talking about this going all the way to this axis of revolution, which is where x is equal to 0. Okay. This is the whole region of w of y right here. So this would be my big R. The green is your big R. This is the radius of the whole thing from here all the way out. Then you have that teeny tiny circle in the middle, which is going to be v of y, which would represent our little r, which is right here. It's teeny tiny. So this is little r. Okay, so now what we have is the volume being equal to, and I like the pi on the outside, but here they have the pi on the inside, from C to D of your big R squared minus your little r squared dy. So this is a disk, and this is a washer. Okay, so let's take a look and see how this works and sketch our figure. So we want to find the volume of the solid obtained by rotating the region bounded by y is equal to x cubed, y is equal to 8, and x is equal to 0 about the y-axis. Okay, so about the y-axis means perpendicular to y, which is x is equal to something dy. Okay, so we're going to have to fix some of this stuff, but we need to take a look and see what the graph looks like. So let's sketch this graph. Okay, so y is equal to x cubed, so we have 0, 0, 1, 1, 2, 2, 3, 4, 5, 6, 7, 8 up there, because I'm cubing 2. Okay, so it's up here. So that means if you remember what a cubic graph looks like, it's going to look something like this. And this is the part of the graph that I want. Oops, like this. It looks like this. So there's one portion of it. And then we want where y is equal to 8, which is this right here, where y is equal to 8. So that caps that off. I think I actually have my bounds, because if I want, and then it says x is equal to 0, which is right here. So we're actually looking for this region right here. It's a terrible color job. Okay. So that means when we're dealing with perpendicular to y, it's going to be right minus left. The function on the right is y is equal to x cubed. The function on the left is x is equal to 0. And then my bounds actually go from 0 to 8. Okay, so what we need to figure out is, we know that this is what's on the right, but we need to solve this for x. So on the right we have, y is equal to x cubed, therefore x is equal to y to the 1/3 power. That's what we're going to be using. And then the function on the left is where x is equal to 0, because it's your y-axis. Okay, so what we're dealing with here, we have our bounds from 0 to 8, so now we just need to put in our setup. This is actually going to be a disk, because your region is completely adjacent to the axis of revolution, which is right here. It's going to go like that. Okay? So we've got the volume being equal to pi times the integral from 0 to 8. And now we need to figure out our, it's actually just our r squared, because it's right minus the left. Okay, so this is just going to be our r. And it's y to the 1/3 power minus 0. So it's y to the 1/3 squared dy. That's my setup. So I actually need to integrate y to the 2/3 power dy. So this becomes 3/5 y to the 5/3. And I have my pi out here. So it's 3 pi over 5. There's the 3/5. This pi comes from the formula y to the 5/3 to be evaluated from 0 to 8. So this can hang out on the outside. So you have 3 pi over 5 times, evaluating at the top, you have 8 to the 5/3 power minus 0 to the 5/3, which would be 0. Okay, this means I could take 8 to the 5th power and then take the cube root, but I have no idea what that is. Cube root of 8 is 2. 2 to the 5th power is 32. So what is that? 96 pi over 5.